Thank you everyone for joining and welcome. Let's go ahead and get started. Today we're talking about pavement resiliency and specifically how does flooding impact our pavements. There we go. My name is Amy Wedel and I'm the Director of Concrete Pavements for Florida Concrete and Products Association. I have 25 years in the cement and concrete industry. Many of that spent working on sustainable construction and how concrete and concrete products fits into that. And most recently, working on pavement here in the state of Florida. Florida Concrete Products Association is the industry representative for ready-mix concrete, cement, aggregate, and concrete paving, as well as associated businesses in the state of Florida. We want to say a big thank you to all of our members for making these educational webinars possible. So today we're going to talk about the need for resilient pavements, and then how do we define resilient pavements? What does that mean? And then we're going to look at some solutions and how we can improve pavement's resiliency to flooding events. So we know there has been an increase in both frequency and magnitude of flooding events. And when we talk about, and this chart isn't even up to date, we see it doesn't go all the way to 2020. So the trend has not reversed itself. In fact, it's even continued. And when we talk about magnitude of storm events, we don't have to go back very far to think of one that was really remarkable. I don't think we've ever seen a hurricane with 185-mile-an-hour sustained winds last for 3 days. So this was both a flooding event and a wind event, and it was very devastating to the Bahamas. And my heart goes out to the people who lost lives and family members and everything they own. But it's a little scary. What if that path had been a little bit further to the west? What would it have meant to have 185-mile-an-hour winds for 3 days sitting on top of Fort Lauderdale, where you have very dense population? So another location that has seen more than its fair share of flooding events, and that's Texas, and it had 4 major flooding events just in recent history. So we see this increasing in frequency and difficulty in being able to predict what to expect the impacts for our pavements. And most notable was Hurricane Harvey. The flooding covered the entire state of West Virginia, or the equivalent of the state of West Virginia. Here, North Carolina, they had over 2,500 road closures due to hurricanes and flooding events. What were the impacts on those pavements? So here in Florida, we also have to think of a different type of flood event, and this is called sunny day flooding. And this has nothing to do with rainfall. This is actually a high tide event, and we're seeing that increasing across this, particularly in South Florida. And the king tides, this comes in the fall and the spring, and every day at high tide, certain areas and certain roadways will flood. An ad hoc working group came together to try and help municipalities, cities, and counties plan for these increase in flooding events. And there's a range of predictions about sea level rise from one extreme to the other, but they wanted to have a uniform plan so that everyone could be working off of the same middle of the road numbers. And we know when we're planning for infrastructure and pavement, a minimum design life would be 20 years. Now we'd like to see 30 or 40 or 50-year pavement design life, but with a minimum here, if you look at 2040, we're anticipating 10 to 17 inches of additional sea level rise above the 1990 base level. So we need to prepare and plan for increased flooding events. So this road here, this happens to be the road I live on in Hollandale Beach, Florida. And I can literally look out my window and tell you that the number of flooding days this past fall was an increase over the past year. And the number of hours each day that the road would flood was also increased. So this is something we need to take into account. And of course, I'm looking and wondering what it's doing to these pavements. A few neighborhoods have taken things into their own hands and had to put up no wake zones and finding new places to go on their paddleboard. Now, I want to differentiate here. When we're talking about flooding events and impacts on pavement, we need to be clear when we're talking about a washout event, and this is where fast-moving water has eroded the base, and it doesn't matter what type of pavement you have, whether it's asphalt or concrete, you're going to have a road failure. So this is a different type of event that we also need to plan for, but today we're more specifically talking about inundation. And this is where the water is not fast-moving, it's rising and falling, and it may in completely flooding the roadway. So this can be differentiated by pavement type on the impact of this roadway. The one other thing to think about when we want to talk about why do we need to plan for resiliency, and this has to do with funding. So we are seeing, and probably will see more of, funding for infrastructure being tied to taking into account resiliency of our pavements in preparing for an increase in flooding events. So I think it's clear we need to talk about resiliency. We need to prepare for it the best that we can. But what do we mean by that, and how do we define resiliency? So resilience, the ability to resist, absorb, accommodate, and recover from the effects of a hazard in a timely and efficient manner. This is how we're defining resiliency. Now, I want to take a step back for just a moment and differentiate. Sustainability was talked about a lot in the past years, and now we're talking about resiliency. So they are different, they relate to each other, and there's some overlap. Sustainability is development that meets the needs of the present without compromising the ability of future generations to meet their own needs. Here we're talking about the triple bottom line. We want to meet the needs of society at a feasible cost with minimal impact on the environment. So we have to balance these three aspects to come out with the best result. Now, resiliency, if we have a pavement that is able to withstand a flooding event and not be damaged or destroyed, that pavement is meeting the needs of society by allowing it to still be in use without having to be rebuilt, which of course is a big economic impact, as well as not having to use additional raw materials. So there's an overlap. And resiliency, you could almost say it's the ultimate in sustainability, because you have this long life that is there to meet the needs of society during an extreme event. So resiliency planning. A good resiliency plan is going to protect or prevent against a natural disaster to the best of its ability. And it's also going to mitigate the impacts from that event. Now, if we do these first steps well, then we have to put less emphasis and effort into our response and our recovery, because our roadways are still there and they're still functioning. So that's the basis of resiliency. So in roads, we want to look at, when we have a flooding event, what does that do to the performance of that road, and how quickly does it recover? So here you can see that the green line has a higher resiliency. It's recovering quicker, and it's recovering to a higher functional level than the red roadway. And then you also have this blue line, and this is what we call hardened infrastructure. And it means that it has the ability to raise the level of performance of a roadway following a flooding event. Okay, so this is the small town of St. Mark's during Hurricane Michael, and the Waukulla and the St. Mark's River were pushed up into this town. So what happened to these pavements? So we got to go back to the fundamentals of what is a flexible pavement, how does it function, what's a rigid pavement, and here we can see illustrated that our flexible pavements rely on the base layer and the subgrade for its functionality, that it's actually the weight axle load is being reflected down into those sub-base layers, and it needs that to be able to function. Now, concrete, on the other hand, is a rigid pavement, and what it does is it spreads the load of the wheel across that slab. It is less reliant on the strength of the subbase. What it needs is not a high strength, it needs a uniform strength. So now you can start to see why maybe concrete is going to be able to withstand a flooding event. So this blue here at the bottom of the screen, this is indicating a flooding event. So what's happening to the strength of these base layers? What's happening to our flexible pavement and our rigid pavement during this flooding event? And so here's some testing on different types of soil in dry conditions and soak conditions. And you can see in the inorganic clays, there's an average decrease in strength, somewhere around 30%. Clay, sandy soil, decrease around 20%. Silty soils, 30%. And silty, sandy soils, the average is 40, but it goes all the way up into some, one of the samples losing as much as 65% of its strength. So on average, in a flooding event, the base layers are going to lose somewhere between 20 to 40% of their strength. Now, Australia is another place that has seen a lot of flooding events. So what they did, knowing that there's this reduction in strength in a flooding event, one way they chose to make their roads more resilient was to add it into their design standards. So when they're designing a road and they want to make sure it can withstand a flooding event, they are building it to the strength of the soaked base layer. So this is another way that we can make our roads resilient. The next question we need to ask is, when we have a flooded pavement and we have that reduced strength, how long does that last? How long are these pavements taking additional strain and having damage because of the loss of strength in the base layer? Now this road happens to be US 441 in Alachua County, and I believe this was Hurricane Irma was a flooding event, I'm not sure. And here you can see the pre-flooding strength in the southbound, northbound, 16,000 PSI. And you can see the significant reduction of the flooded pavements. And they wanted to see how long does this reduced strength last. And they continued testing for 6 months, and it did not recover during that time period. So what we know from some other tests and some other examples, it can take up to a year for that base layer to really dry out and to regain its strength and its functionality. during that time, there's a lot of damage that is being done to the pavement layer, and it can reduce the lifespan of that pavement. So we've been talking about the flooding event and what impact that has on our pavement. What we also need to think about is what we're calling secondary impacts. So the flood is reducing the strength of our pavement. And ideally, we'd like to wait for it to dry out before reloading the pavement, but that's just not practical. And so we know that there's going to be rescue and relief efforts in the days following the event. And we know that there's going to be recovery and cleanup, which could last up to a year or more in some big events. So back to Hurricane Michael for a minute. This is US 98, and the roadway design is for this small local community. It has around 1,700 buildings, or had 1,700 buildings, half of which were completely destroyed, and most of the rest were damaged as well. So this road underwent a complete inundation, storm surge of 14 feet, and the road design was not for heavy traffic. You have I-10 just a short ways north of here, and that's where your heavy traffic is. So this road is for the local community. So during Hurricane Michael, there were 2 million ready-to-eat meals, 1 million gallons of water, and 40,000 10-pound bags of ice brought in to this community. Additionally, there was over 1 million cubic yards of vegetation debris that was removed from this town. And we know a million cubic yards of debris is equal to about 65,000 dump truck loads. So this was really not the plan for this small community to have an additional 65 dump truck loads on their local roads. And again, Mexico Beach, this is a small town. There was actually a lot more debris that was never removed. It was just left in place because it was in a rural area. So let's take a look maybe at another storm, Irma, in 2017, and this really affected many areas of the state. So we had 4 million cubic yards removed from Miami-Dade County, 3 million from Palm Beach, 3.6 million from Collier County, 2.7 from Lee County, and these are, I didn't have the numbers from all the counties, so these are just a few examples. But this is, so again, 65,000 dump truck loads per 1 million cubic yards of debris. So this is, again, a lot of traffic that most likely these small roads were not designed to handle. And looking across the U.S., some other examples, 8 million cubic yards in Houston following Harvey. Superstorm Sandy, 6 million cubic yards just within the state of New York. And Hurricane Katrina had 38 million cubic yards of debris. So following Katrina, the Department of Transportation in Louisiana, they did some research on what impacts this flooding event had on their roadways. And because they didn't have pre-event data, what they did was take a satellite and look and see where roads were flooded and which roads did not flood. And they did a comparison, strength comparison of those two locations, both for their asphalt pavements and their concrete pavements. And what they found was their asphalt pavements had a strength loss equivalent to about 2 inches of new asphalt. And they had $50 million in damages to rehabilitate those roads that were impacted by Hurricane Katrina. In contrast, their concrete pavements saw little effect from this flooding event and were able to continue on serving their community without having to go through repairs or early rehabilitation. Another research study back to Australia that saw a lot of flooding events, and they did some research and looked at their pavements, and basically a similar conclusion that rigid pavements perform the best under flooding conditions. It's the more flood resilient pavement type. So Texas is a predominantly concrete pavement state. And here in Houston, they saw several flooding events. And once the water dissipated, they were able to reopen these roadways to traffic and without having to do any repair. And they're continuing to function and serve the community even after massive flooding events. So what we can see is that concrete doesn't have the same drop in performance from a flooding event, and it's able to quickly recover and continue to serve that community. Our flexible pavements, on the other hand, have a harder time in their performance until that base layer can dry out, which takes a long time. And during, while it has that reduced strength, they're also being hit with these secondary impacts, this rescue and relief efforts and the debris removal. So they're continuing to have stresses that they were not designed for, and this can lead to early rehabilitation. So now we've talked about the negative, let's talk about positive. There are a lot of things that we can do for resiliency. There's some great things out there, and that's what I'd like to talk about next. So what are our options to achieve resiliency? One way would be to elevate the road. This is not the preferred way. This is a last resort because this is a very expensive option. Now, there may be some locations that this is the only option and it's what we have to do. But raising our roadway is a last resort as it really takes away funding from other things we can be doing. However, we have seen some headlines. This is from a few months ago in the Miami Herald, where they are talking about abandoning a road because to elevate this roadway would be really expensive. Now, for the 30 homes that live along this road, that's a really tough decision. This, again, abandoning this is not an option that we want to use if we can at all avoid it. In some cases, abandoning a road may be okay if you can reroute to other locations or there's not significant homes or businesses along this roadway. So this is another option that we want to avoid if at all possible. So what can we do in an economically feasible way and a positive way to harden our infrastructure? How can we, when a road has come to the end of its design life and it needs to be rehabilitated, are there ways that we can rehabilitate that road, rebuild that road to make it more resilient prior to an event? Or what can we do following an event to make that roadway more resilient for a future event? So these are called the hardening activities, and they are stiffening up the pavement to withstand the flood event. So today I want to talk about two options that are especially good when we're talking about resiliency. So concrete overlays and fold-up reclamation are two ways to harden your infrastructure or build in resiliency. So what is a concrete overlay? This also used to be called white topping. Now we just use the term concrete overlay. And bonded concrete overlay. So this is building on top of an existing roadway and using that roadway so in a bonded case, it's part of the structural system. In unbonded concrete overlay, asphalt becomes a base layer. And we know that asphalt is a good base layer for concrete. So depending on the condition of that roadway, would dictate how we choose to do that concrete overlay. So we are seeing an increase in concrete overlays across the U.S. Up to 13% of new concrete pavement is concrete overlays. And it makes sense because this is a financially viable option to have a very resiliently robust pavement that's going to last a long time. So here's how specifically does that concrete overlay build in resilience. And this goes back to the basic functionality of a rigid pavement versus a flexible pavement. It's not as reliant on the strength of those base layers, which we know get weakened during a flooding event. And it could be that it also raises the road. It doesn't have to, but it could raise the road. And in some cases, maybe in my neighborhood where it's only flooding by a few inches, you know, during king tides, this could also raise the road out of those flooding events. California wanted to gather more data on concrete overlays to really understand their performance and their lifespan. And they have a heavy vehicle simulator testing site, and they put down several different thicknesses of concrete overlays, and they did several different joint spacing and ran it through this heavy vehicle simulator to understand the performance. So here we can see they start out with full legal load, the 9 kips, and this in dry conditions. They ran it through 70,000 reps. There was no load failure. They upped the weight, ran it through another 70,000 reps, no failure. And then they raised the heavy vehicle simulator to double the legal limit on the roadways. And they ran it through again, and they didn't have a single failure. And then now this testing was not originally designed to be a test for flood events, but they had the ability to do the flood testing as well. And since they didn't have any failures, they were, okay, well, what really is the capacity of these concrete overlays? So they flooded the pavements and ran the heavy vehicle simulator over it again, another 70,000 reps, no failure. So they went to even a higher weight limit, ran it through again, and they finally had their first failure. So it was not designed to look at concrete overlays in a flooding event, but indeed they found that this is a very resilient pavement and can last through very heavy loads in flooding conditions. Of course, we understand now that we need to build in resiliency, and we've looked at some ways to do it, but we know that the financial aspect has to be balanced with the resiliency, and we have to take that into account. And that's what's great about the concrete overlays. And we can look, this is a road in Colorado, and it had reached the end of its useful life, and they needed to rehabilitate this roadway. And they compared asphalt rebuild to a concrete overlay, a 6-inch unbonded concrete overlay. And you can see here that even in the construction cost, the initial upfront cost of the concrete overlay is a little bit less expensive. And then when you also take into account the rehabilitation and the maintenance cost, you can see that the concrete overlay is a clear winner here. And this is not even taking into account resiliency. Colorado has not, and you can even look here at this picture, and this is a road that doesn't have a high likelihood to have a flooding event. So this is just looking at it as an option to rebuild the roadway. But now we know, in addition to that, that it's also going to build in resiliency. Here in Florida, we have our own concrete overlay test section. And this was in New Smyrna Beach, US 1. And the test sections were put down in 1988 in different thicknesses, 6 inches, 7 inches, 8 inches, and different joint spacing and a few different variables to see how this road performed. And you can see the existing condition in the top, the asphalt roadway, and then the overlay here in the bottom photograph. So what happened? That was a while ago. We did an evaluation on these roads back in 2015, and you can see the 6-inch overlay had about a 35-year design life, and this is when it reaches 15% slabs cracked. The 8-inch overlay, on the other hand, appears that it's going to last over 50 years. So very good performance. So what about the cost? And here, we like to do life cycle cost analysis, and it gives us a lot of information, but we need to think about what is the appropriate lifespan to compare if we're looking at how do we quantify, and there are ways to do this. If we're looking at a 20-year design life for flexible pavement and a 50-year design life for concrete pavement, how do we fit that into the life cycle cost? And the other discussion that's out there is the discount rate. And you can see here that you have very different results based on that discount rate. So I'm not going to go into that argument today. I just want you to see that based on your inputs, you can have different results. And in this case, this is not even taking into consideration that there could be a flooding event that could shorten the lifespan of that flexible pavement. So this was not thinking about resiliency. It was just looking at the cost and the lifespan of these different pavement options. So once you have a concrete pavement, we know it's going to build in resiliency, but what else do you get with that? So we know that concrete also brings us lower temperatures. Here we have the concrete sidewalk with 132 degrees, aged asphalt lightened is 141 degrees, and the newly resurfaced asphalt is 152 degrees. So once you have that concrete overlay, you're going to get these additional benefits in both cooler temperatures as well as improved safety. And we know that the lighter colors are going to be more reflective, and this can reduce accidents. So these are side benefits that are a little harder to quantify financially, but we know they do exist. Okay, so that was concrete overlays. I want to talk a little bit now about full depth reclamation. It's another way to build resiliency into our roadways, particularly when we have an asphalt roadway that has reached the end of its useful life, and it has to have either a major rehabilitation or a rebuild. Full depth reclamation, FDR, gives us an alternative in rebuilding this roadway. So here's kind of the steps in the process. You have a pulverizing of the surface asphalt, the granular base, and even down into the subgrade. Now, depending on if you need this roadway to maintain a certain elevation, then you could take out some of this material to allow room for your new surface. However, if you want to actually build the road up to a higher elevation, you can put your new surface material on top of that without removing any of the pulverized material. So, okay, now you've got your pulverized material. You're going to add some cement. You're going to mix this in and compact it. And that is your new stabilized base layer. And you can put on top of that base layer asphalt or concrete. Of course, we'd like to see you put concrete on top of it, but even with asphalt on top of this full depth reclamation, you're going to get a more resilient roadway. So that stabilized base layer is also performing the function of spreading the load over a wider area and being less reliant on the strength of the subgrade. And even when that is flooded, it's also going to help keep that flooding and that moisture from destroying your road and having it have a lot of deleterious impacts. So here, this is showing the red is with your full depth reclamation and showing that the road's ability to have it to better take strains of the asphalt pavement. And we could understand that this would also be amplified under a flooding event. And here, this particular subgrade, they have blended in 4% Portland cement into the pulverized material and compacted that. And again, full depth reclamation is going to give you increased resiliency to a flooding event. It also has the benefits to environment and sustainability benefits of you're having a huge reduction in the number of truck trips. You're not having to haul the old material away and bring in new material. So you're using less raw material. You're having to send less material to the landfill. And of course, you're also reducing your diesel consumption. So this example is for 1 mile of road, 20-foot wide, 2-lane road with a 6-inch base. This is how you can reduce, obviously this has a financial impact and an environmental impact, as well as building in resiliency. So some conclusions from today is we understand there is increasing frequency and magnitude of flooding events. I would say there's also an increasing uncertainty surrounding these events, and we need to prepare for them. And we want to do that anyway, but we're seeing where there is a stipulation in some funding for infrastructure that's requiring resiliency. So we need to take that into account as well. So in areas, some areas are more flood prone than others, and we're seeing increasing areas that are becoming flood prone. And we need to look at ways that we can stiffen or harden that existing infrastructure. And that can be done before an event if the road has reached the end of its life and it needs the rehabilitation, or it can be following a flooding event, bringing it to a higher standard, higher strength and resiliency following that flooding event. Another option that we can use that we saw was we can design the pavements based on a soaked subgrade strength. So this would also give us a resilient pavement. And we looked at both concrete overlays and full depth reclamation as two cost-effective ways that we can build in resilience and harden our infrastructure. And I say the most important point here for last, and that is that the concrete industry is here to help you, whether you're a city engineer or a planner or however, you're in part of the process of planning our infrastructure, we want to help you look at your particular situation and find the best solution to economically, to build in resiliency, to make sure that that pavement is functional during a flooding event.